اوكي، ونعمل شيرنج للشاشة تبعتي. بسم الله الرحمن الرحيم. فأخذنا مقدمة عن الأوبريتنج سيستم، ما هو الأوبريتنج سيستم، وقلنا الأوبريتنج سيستم هتكلم إنجليزي ترى، بس يمكن ما أدري يكون أفضل. فلو في أحد ما عنده أشياء مش واضحة يرسل لي على الواتساب أو على عفوا على اللينك اللي أنا حرسله لكم حق الاتندنس. طيب، so the operating system is something, a software that will help the user and the hardware and the other softwares to work together, as simple as this. Right? So if you look into the slides, we said, okay, we explained this diagram, and we said that there are some application software that they would like to communicate and use the resources in the hardware. So the operating system is a system software that will help the application softwares to do this. Also, if there is a user, okay, and the user has either a simple user without any permissions, or an administrator or a user with a lot of permissions, he can use this hardware. Right. So as you see here in this image, we have the user level, the application level, the operating system level, and the hardware level. So the operating system come in between the application and the hardware, and the user here, okay, he uses the applications. Okay, so the user cannot access the hardware directly, and the applications cannot access the hardware directly. So the operating system is the software that do this. And we said that you can look into the operating system as it's an resource allocator. Also, you can look at it as a control program. So it all define the operating system. And we said that this big software, that is the operating system software, consists of 4 essential subsystems or sub-managers. Okay, so these all are softwares. And the additional one, number 5, is the network manager, which is not essential, it is additional. So it depends on the system you are using. Okay, and we look into the tasks of every manager. Okay, overview about all of kind of these things. Okay, now for today, inshallah ta'ala, we will take a look about the computer system structure. So how it is structured. And when we say a computer system structure, we mean the hardware. Okay, so this is the hardware. So it's an overview because some of you maybe never saw this before, but this is important. So you must realize how the operating system software is working. So you need to have an understanding of how the computer is organized or how the hardware is structured. So this is important also. Right. So the computer system, in order to operate or to work, so we have multiple hardware. So we have here the disk. The disk is a hardware. The mouse, the keyboard, printer, the monitor. Okay. So all of these kind of hardware, these are addition. Okay. This, all of them are addition to the main motherboard. So I will just write something here, small rectangle, just for you to realize how it might look like. All of these are available on the motherboard, on the motherboard. So some of you maybe don't remember what is a motherboard. So the motherboard is the green board inside the computer that connects everything to each other. So maybe if you don't remember how it does look like, I will show you a little picture here. Okay, so this is the motherboard. This green area here is the motherboard, and on the motherboard you find the CPU at the middle, somewhere here in the middle, and some other components. So everything in the computer is connected to the motherboard. Okay, so this green uh, board. Okay, now inside this motherboard you will find the CPU. Okay, and for every device attached or linked to this board, there is a controller. Okay, so this is another hardware also. Now the memory also, and when you say memory we mean the RAM. Okay, so the RAM also is a hardware attached to the motherboard. You can add RAM, more RAM, and you can remove the RAM. So the RAM is a device, the disk is a device, the mouse is a device, the keyboard is a device, the printer is a device, and the monitor is a device. So all of these things outside the board are devices attached or linked to the board. Okay, now inside this green box we have some kind of hardware that try to communicate with these devices. So we have a hardware here called disk controller, okay, so that it can control the disks. Okay, USB controller that can control the printer or the keyboard or the mouse or any other devices that work on the USB. And we have the graphic adapter, and the graphic adapter is also a hardware that enable the monitor to work. So all the colors on the monitor, all of them, or these small points, we call it pixels. Okay, pixels. The pixels, all of it, it is saved in some sort of a memory. It is saved in the memory, in the RAM, but who controls this is the graphic adapter. Also, this adapter has its own, sometimes, it has its own CPU. It has a processor for it. So it makes the graphics faster, especially in gaming. If you want to play a good game, so 3D game, so your graphic adapter or graphics card, they call it sometimes, it should be with high specifications. Right. Now, all of these controllers, when they communicate with each other, they communicate through these lines. These lines These black lines represent something called a system bus. A system bus. Okay. And why they call it a bus? It's, if you look into it as in a symbol terminology, you think that there is a lot of data, 0, 1, 1, 1, 0, etc., etc. So this data or this set of zeros and ones, they are transferred in small lines like this. So this is these lines, small lines, they transfer the bits. Okay, so sometimes you have 32-bit lines, and in some computers you have 64-bit of lines. Okay, so these lines here, all of it, this is called a bus. It's like a school bus that is uh, that carry these signals or these zeros and ones all as a group in one time. So it's very fast. It's very fast. So the signals, the bus that go out from the CPU, it's very fast. But the signals that come from the devices here is slow. Okay, and this causes some problems in the operating system. So we will see later, inshallah, how it is resolved. But anyhow, at the end, all of these devices are connected to the controllers, and in order to be controlled. So it is simple as you turn it on or you turn it off. You read data from disk or you write data to the disk. Okay. The keyboard, you read the keyboard buttons, and for example, you have pressed a key of A or B or C, So you transfer this data through the controller through the system bus. Uh, this kind of computer system structure is very general for most of the computers. Okay. It gets complicated when you have multiple CPUs, for example. Um, some servers might have some computers, يعني supercomputers, might have many CPUs, thousands of CPUs, tens of thousands of CPUs. So it gets more complicated. But in our course, we will just take only some basics, inshallah ta'ala. طيب. Now these devices, as I mentioned before, mouse, keyboard, etc., generally we describe it as I/O devices. I/O. I stand for input and O for output. So either you input data or you output data. It's as simple as that. You input 00001 or you output 0001. So the bus transfer into the devices or out from the devices. Okay. So the I/O devices and the CPU can execute concurrently. Now we are describing here how the computer system work. So this is how the computer system work in simple terms, يعني just general. Later on, inshallah, we will take we will take a look into some more details about how does it work. Now, the CPU and the devices, they can execute concurrently, يعني at the same time. At the same time. Each device controller is in charge of a particular device type. Responsible يعني in charge of يعني it is responsible. Every controller is responsible for every particular type. As I mentioned here, the disk controller, its responsibility to control the disks. USB controller, its responsibility to control mouse, keyboard, printer, and the graphics adapter, its responsibility to control the monitor. Right? Okay. Each device controller has a local buffer. Now, some of you may say, okay, what is a buffer? So a buffer is simple as a data holder. Okay, it holds or saves that data, our data. Okay, so any data transferred from the device, there is inside the controller, there is a buffer where it saves this data. Type. Each device controller type has an operating system device driver to manage it. Okay, now this is new. If you remember, last class we said, okay, if you go back here to this big, this one, okay, we said that there is a, inside the operating system software, the operating system software, it has a processor manager, it's a software, and a device manager, it is a software, and a file manager, it's a software, and a memory manager, it's a software, all in one softwares. And these are the general four managers. Okay. Now what we are saying here now, here, we say that each device controller type has an operating system device driver to manage it. Now, what is a device driver? A device driver is a software also. This is a software. And this software, you install it on your computer to enable the operating system to communicate with this particular device. Right? For example, you purchased a new flash drive. Okay. When you plug in the flash drive into your computer, it does not work directly. It takes few seconds until it works. So what happens during these few seconds? What happens is the operating system try to recognize what type of flash is this device, and then it goes to the internet and download the most recent device driver software. It downloads it and then it is installed. After that, the flash starts working. Or maybe you purchase an external disk. The same thing happens. Okay. So every time you add a new device to your computer, you attach it, you plug it in. Okay. So this device has a device driver, a software that is additionally installed to the operating system. So if you look into the memory, so we have the OS here, and we have the device driver software, for example, the first device driver here, and we have another device driver here, and we have many device drivers in memory. All of them, the OS has communication with them all the time to make sure everything is working smoothly inside the memory, all of it inside the memory. Okay, so there are softwares or programs they are running, but they directly communicate with the OS to make sure all the drivers, all the devices are working. Right. The other thing we have here is the CPU. Right. Okay. Right. We have here the CPU moves data from or to the main memory to or from the local buffers. So what does that mean is inside, I will take a copy of this. I'll make it larger a little bit. Okay. So we have inside here we have a buffer. And here we have a buffer. And here we have a buffer. So what happens is the CPU, for example, send an instruction 0001111110, etc. to the disk controller here. And maybe this instruction has some data need to be saved. Okay. For example, keep the disk on all the time. I want the disk to be always on. So this data is saved here, 11100001 here in this area, inside the buffer. Okay. Also, if the CPU would like to read the data from any other controller, so the data here is saved. For example, the printer here finished printing the jobs, يعني finished printing. So it might send data inside the buffer here. So this is a buffer of the printer, and inside this, the data inside here, it means that the printer finished the printing job and it's ready for new jobs. Ready for new jobs. So this kind of data is saved inside the buffer somewhere inside the hardware. Okay. Also the graphic adapter, the same thing. There has buffers. So here a buffer, here a buffer, here a buffer. So it saves the data. As simple as this. Okay. Fine. So either you move data in or to the buffer, or you copy it or you take it from the buffer. Fine. Fine. Input and output, input or output, is from the device to the local buffer of controller. Okay, this is straightforward. Right. The device controller informs the CPU that it has finished its operation by causing an interrupt. Now, here, this new term we will talk about it inshallah next class in detail. The device controller inform the CPU. So this is a communication between them. That it has finished the operations by causing an interrupt. So what does an interrupt means? It's a piece of software, a little program that is executed so that this information is reached to the CPU or reached to the device controller. Inshallah, later, inshallah, we'll talk about it. But for now, just remember that the interrupt is some sort of a piece of program, small program, very small piece of a program. Okay, inshallah, we'll see it later. Right? Okay. I will now talk about something important about the operating system. Now we have in the operating system, we have something called dual mode operation. Dual mode operation. And by this we mean that we have something called the kernel. Now the kernel is a system software that never stop. Now the kernel means, the word kernel, it means something like core, something like mandatory, something like yeah, internally important. It must not stop. Okay, it's like the heart. Okay, the heart of the body of the human being must not stop. Other than if the heart stops, then the human being will die. And the kernel is the operating system heart, that it should not ever stop. Okay, so it runs forever. Now, why this is important to realize it? Because for you now, if you are using your PC, the PC is a simple machine comparing with other computers like servers. So if your PC, you can turn it on and you can turn it off. Simple, no problem. Okay, so nothing happens. But suppose that the operating system is a server inside STC company, and this server is an internet service provider, ISP. Suppose the company STC, they have this big server here, and there is like, let's say, 10 million users accessing the server at the same time. 10 million people are using internet service at the same time. Now, if this operating system stops working, so this is a big crisis for STC. They are losing money, they are losing customers, they, so they cannot risk putting or shutting down their server off. This server must work 24/7, يعني all the time, all the hours, every week, forever. Now, once you have a server and you need this kernel to continue working forever, things get more complicated. So this is why we insist here when we say, okay, at the kernel never stop. Because you must learn that in the future, inshallah, you might work uh, on servers administration, not only a simple PC. Right? And this is why in this course we are going to teach you Linux operating system. So why Linux? It is similar to Unix. And why Unix or Linux? Because both of them, they are very common and widely used as servers. So they are operating system not only for one computer, they are an operating system for many computers. So now suppose there is one computer here and another computer here and another computer here. Okay, so there's a lot of computers and many users, all of them trying to connect to this kernel. They try to take uh, permissions to access the hardware. So from the same from the same point of view, we describe this one here, this small, where is that one? Yeah, this one. Okay, now the system software here, this system software, uh, here lies the kernel. We are talking about the kernel. So the kernel is a software, an operating system. We call it the kernel. So a system software might be, part of it is a kernel, and part of it is the other software that maybe utilities or communicating with these users or applications. But the kernel must not stop. So this is why when we look into the system software here, and we look into the operating system software, here the operating system, we can say, okay, this is the kernel and the other software that do the other stuff. So so you try to link the things to each other. Okay, right. Okay. Uh, so from this sense, the kernel must be privileged. يعني privileged has all privileges. And privileges is something like permissions. It is allowed to do anything. It's the super software that can do anything it likes. Okay. And then we have, so it is privileged, يعني it is trusted to access all the resources. All the resources. Okay. And we have, other than the kernel, we have the user applications, and these user applications are untrusted. Why they are untrusted? Because the operating system must secure and make sure the hardware is safe. Okay. Now, from this point of view, we should always, the kernel will check these applications if it is trusted or not trusted. So there is a security issue and reliability issue. So what does a security issue mean? Okay, now the program is, we suspect that this program might read and write the data it should not, and it's not allowed to read and write. Maybe in memory, inside the memory, maybe there is some data there that has the username and password for the users. Now, if the user application is trying to access username and passwords without permission, so this is untrusted application. So it's a malicious program. It is suspicious. It is risky. It is breaching the security. The other thing is, is it reliable? Is it reliable? If I allow this application to access the memory, is it reliable? I can rely on it, and it will not access other wrong locations in memory or crash, make access location in memory it is not allowed to access. So it will crash the machine and make cause the computer to hang. Huh? So so these two things are very important. So the kernel will check the user application from the security perspective, from the reliability uh, perspective. It is okay, then it will allow the user application to run. طيب. Um, Now, as I said before here in this small, we have many users, and the kernel would like to fulfill or give to every one of them access to the resources. And we said from last class, the resources is like the RAM and the CPU mainly, and the files or the disks. Okay, so that it can access data, it can execute instructions. So these are the main resources we have. Now, suppose the three users would like to uh, access the same file on the disk, the same file. So this file is a resource on the disk, and these three users would like to access in the same time. So the kernel should manage these accesses and give priority who should access what. Okay, so this is why these resources are shared. So this point is sharing system resources require operating system to ensure that an incorrect program cannot cause other programs to execute incorrectly. Okay, so this is the major thing, inshallah. I hope inshallah it is clear. طيب. So we can say at the bottom line of this class regarding we can say that we have the operating system have dual model of operation in order to protect itself from other system components. So we have two. One is the user mode, number two is the kernel mode. So if you are in the user mode, the operating system is running using a user mode. So he has limited privileges, limited access permissions. The kernel mode, he has full access. Right? So all OS operations in kernel mode, these are very important. So we can call it sometime like monitor mode, kernel mode, system mode, whatever. Okay. But the most important thing now is that the user mode has no privileges. Right? Every time the operating system work, it switches between the user mode and the kernel mode in order to give access depends on each what is requested. This is a summary of the kernel mode. In this mode, software has a complete access to all hardware and can execute any instruction the machine is capable of execution. The user mode is the rest of software runs in the user mode, which is only a subset of a machine instruction is available. بس يعني limited. Right? So this is a simple comparison between the kernel mode and user mode. Now you in the lab, inshallah, you will have a username and password, and you can try yourself in the lab later, inshallah. I don't know if this week or next week, how to program in these modes. Okay. طيب. Inside the hardware also there is a they put a bit يعني a zero, okay, to monitor, or one to indicate as a user mode, so it can distinguish between the modes. So it's a value saved, so it can have these kind of modes. طيب. Just enough for today. I'll stop here inshallah. Next class we will try to explain the what does a system call mean, what is a process, what is an interrupt, how interrupt handling is important, inshallah ta'ala. Okay, I'll send you the link for attendance. Jazakumullah khairan. Okay. If you have any questions, you can put it in the chat, or you can write it inside the attendance link.